Alright guys, so now today we're going to be talking about the nuclear model of the atom and isotopes. So the nuclear model of the atom is pretty much just it's a model that describes how the atom is structured, and basically if we go here it's described as a small core tightly densely packed nuclei with here let's just use hydrogen, which has one proton and one electron. So it has a small densely packed nucleus with an electron orbiting around it, and it's sort of just going in every which way it can. So that's sort of what it looks like, and it builds this cloud, and the electrons sort of move around randomly in that cloud. And that's sort of all the nuclear model of the atom is. It describes a very densely packed nucleus with electrons flying around all over it. Um, Subatomic particles, just sort of a little bit of a history. At the end of the 19th century, it was discovered that they have negatively charged particles, which were called electrons, which had a mass smaller than the hydrogen atoms, and therefore they had to go searching for the positive charge. There was a very famous experiment called the Rutherford experiment. That's how they did that. Uh, that's not in the syllabus, so you can go look at that on your own time. So, important things to note here is that this atomic radius is much smaller than the nuclear radius by about 100 times. To give some perspective, the atomic radius is about 100,000 times bigger than the nuclear radius. And the nucleus is very, very, very densely packed. It's less than 1 trillionth of the volume of the atom overall. Just that nucleus. That's how densely packed it is. And then when we talk about isotopes, atomic number is defined as the number of protons in any given nucleus. So that's what makes each element an element. That's what defines each element, the number of protons in the nucleus. So all carbon atoms will have 6 protons in their nucleus, and all lead atoms will have 82 protons in their nucleus. However, sometimes they have different masses, and that's because they can vary in the number of neutrons they have. Protons have a positive charge, electrons have a negative charge, and neutrons have no charge. And sometimes that exists. So in order to account for the fact that sometimes they have different numbers of neutrons, we have what are called isotopes, and they just weigh more than they just weigh more. That's the only difference really, because they have more neutrons. There's some really interesting particle physics that we can go on to discuss, which you're not required to know. So really, that's all there is to it. Lastly, I need to talk about isotopic symbols, where they are described using this notation below, where A is the mass number, Z is the atomic number, and X is the elemental symbol. Note that generally they tend to just write it like this, because X implies Z. And then lastly, when we consider ions, ions are charged particles. They can have either a positive charge or a negative charge. Positively charged ions are called cations. Negatively charged ones are called anions. Um, Atoms and molecules are by definition neutral and thus have equal numbers of protons and electrons. Ions, they get their charges by either having an excess or a deficit of electrons, since don't move. So, so when we talk about, we'll go into a little bit more when we talk about ionic bonding, the loss and gain of electrons. However, symbols encompassing both isotopes and the ions are shown below. So 6828 Ni2 plus. There are 28 neutrons as given here by this 28. The number of neutrons is given by the atomic mass minus the number of protons in the nucleus, so 34, and the number of electrons. We know we have 2 plus, so there must be a deficit of 2 of them, and we know that neutral nickel has 28 electrons, so therefore it has 26, because 28 minus 2 to account for that little deficit there. When you're ready, you can try questions 1, 2, and 3. Pause the video now. Alright, so I assume you've paused the video. Which particle is not in the nucleus? Pretty easy. We know that there's neutrons, protons, and electrons, so it's that one. For part 2, The dense part center is called the nucleus. Most of the volume consists of empty space. I forgot to mention that. Um, it's mostly empty space with the electrons flying around, and then a typical atomic radius. Let's try these three now. These are multiple choice questions, I think. Yeah, they're all multiple choice. So let me zoom out a bit. So try these for now, and when you pause the video now. Right, I assume you've unpaused the video. Typical atomic radius is 100,000 times larger. I mentioned that at some point in the video. The number of which type of subatomic particle determines the identity of the element. Which one? For number 5, it's C, proton. For number 6, it is same number of protons. Yeah. That would be this one, C. And which is atomic example of a polyatomic anion? The answer to that is B. Thank you very much for watching.